Hi, good morning everybody. Today I invite you all for the session of DTFT, that is Discrete Time Fourier Transform. This is lecture number 9. Now under this we will study a beautiful property called the symmetric property today. Now this topic is coming under V2 syllabus for 4th semester ECE students under module 4. This can be also be studied by any other branch students like electrical, E&E, TC, IT, whichever the branch who is having signal process, signals and systems, they can study this, right? Otherwise also, whoever interested in projects doing ME, PhD or BE, signal processing as core domain, some of you in companies you are looking, or some of you are looking to write gates, for all of you, this is a very basic subject. Signal processing is a very common topic. You have to study. You can go through all these signal systems studies, right? Now this is otherwise also other than BE, whoever interested in signal processing area, right? That they can refer all these things. Why? Because this signal processing is the common subject of or a subject of today. Because see that everybody who is having from the villagers to US president, if you take, is using mobile, right? That's why that signal, how it transmits, how it behaves, where is the detections, right? Where is the corrections, receptions, and all these. If you want to know, you can go through all these things, right? These subjects. Now, that's the importance of this subject. Let us do today. In all my previous sessions, we have dealt all the properties. Right, this is the last property, symmetric property, very, very interesting. Let us see what is this. Right, now, for example, I will tell you the significance of this property in the end. Just let me go for property now. Right, if DTFT of x of n, any signal x of n, if you write DTFT, you will get x of e power j omega. That is, frequency domain representations of any signal x of n is given by x of e power j omega. Vice versa, again. Then prove this. 3 things you have to prove. If x of n is real, then prove that if x of n input sequence given is real, right? We will talk there later. Is real, then prove that first one is x star of e power j omega, that is conjugate. This is nothing but conjugate star. X star of e power j omega frequency domain is equal to conjugate of frequency domain is equal to x of e power minus j omega. This plus j omega is there, no? X star of instead of star, this is x of e power minus j omega. This you have to prove. First one. Second one is if x of n is real, your input x of n is real and even, then prove that imaginary of x of e power j omega in frequency domain, x of e power j omega imaginary plus real you will get, no? Imaginary of x of e power j omega is 0. That means whatever x of e power j omega you are getting now in the end, right, that is purely real. If it is, if x of n is real and even, then what you will get is, you will get in frequency domain x of e power j omega, no, it is purely real, you will not get imaginary term. That is what you have to prove second. Third one is same otherwise. If x of n is real and odd sequence, then prove that real term of x of e power j omega, you will get frequency domain x of e power j omega as real x of e power j omega, real e power j omega into plus j into imaginary e power j omega, you will get, no, there real of x of e power j omega term is 0. Only you will get x of e power j omega, no, which is purely imaginary. That's what the statement. You have to prove 3 things. What is that? First, x of n DTFT of is x of e power j omega frequency domain. Then prove that if x of n is real, then prove that conjugate of x star of e power j omega, that is x of e power j omega conjugate is equal to x of e power minus j omega first. Second is x of n is real and even, then prove that imaginary of frequency domain is 0 term, that is x of e power j omega which you are getting now is purely real only, no imaginary term. Similarly, the other way, real and odd, then prove that x of e power j omega which you are getting is purely imaginary. There is no question of real term which is 0. That you have to prove. This is the statement. If you understand the statement, very, very important, right? Proof is easy. Proof is, let us see proof, given. If, what is given? E only is giving x of n is real. Right, x of n, you input sequence which you are giving now, which you are applying now, that is real. Real means what? X of n is equal to x star of n. That means, if suppose x of n is 2 plus 3n, right, let us say real term and imaginary term, then x star conjugate of n if you take, it is, which is nothing but real terms is as it is, conjugate when you take, plus becomes minus in the imaginary, that is 3n, 2 minus 3n. Right, this is same, but always imaginary terms changes. That is what the conjugate. Now both are equal in this case. That's what given. Right, then next immediately, right, that is the assumptions given. Next, then x of n is equal to, what do you mean by x of n input sequence? Which is nothing but combinations of even part plus odd part. Even xe of n plus x naught of n, which we know. We take one arbitrary signal which is nothing but combinations of even and odd. Then DTFT of this is known already, right, is given as x of e power j omega, which is equal to, when you expand x of e power j omega in frequency domain for the time domain sequence, then real part, imaginary part, that's what I said. Real part is xr is real, xr of e power j omega plus j into x imaginary, xi is imaginary, xi of e power j omega, call this is equation number 1. In frequency domain also, you are having real term plus imaginary term. Right? Call this as equation number 1. Important equation. Next, immediately write original sequence x of n for the x of e power j omega using a standard expressions which we know is equal to 1 by 2 pi. Integrations over 2 pi x of e power j omega n into d omega. Call this as equation number 2, which is known standard equation, original equations of DTFT original sequence. X of n is given by this formula. Call this is equation number 2. Then take conjugate of, now what you have to prove? You want to prove this. First one is this. Remember this, what you want to prove. X star of e power j omega is equal to x of e power minus j omega. This one equation number, statement number 1 we are proving. Therefore try to get conjugate terms here. Right, that's why what I will do is, now take conjugate on both sides. For this equation is there, no? Take conjugate on both sides. What will happen? Conjugate of x of n is x star n. 1 by 2 pi same. Integrations 2 pi same. Conjugate of x of x of e power j omega is x star of e power j omega. Right? That's what I am writing. X star of e power j omega. Then conjugate of e power j omega n is plus e power j omega n is minus e power j omega n. Minus e power j omega n. See this? Conjugate of e power j omega n is, this is x star of e power j omega. Just write star here, e power j omega n into d omega. Right? Just conjugations we are taking. Right? Now, immediately call this as equation number 3. Now, x star of n, we can write this as 1 over 2 pi, integrations of 2 pi, x star of e power j omega as it is. Now, e power j omega n, what I will write is, I will write it this way, e power plus j of this is actually minus. Yes, conjugate whenever you take, this conjugate you take, x star n, here x star of e power j omega, then this is e power plus j omega n is there, no? E power minus j omega n. This is missing. Please correct it. E power minus j omega n. Now I am writing this e power minus j omega n as e power j plus j minus omega inside, minus omega n into d omega. There is a simplification purpose. For the simplification purpose, I am writing this as this. I will tell you later. Call this is equation number 4. This is equation number 3. I know from the input, x of n is real. That is given. X of n is equal to x star of n. Given. We can write now this equation as, instead of x of n, I am writing x star of n. Both are same. X star of n as x of n. Right? Now, which is equal to 1 by 2 pi, integrations over 2 pi, x star of e power j omega into e power j minus omega n into d omega. Call this as equation number 5. Right? Now, compare equations 2 and 5 we can write. For example, 2. This is equation number 2 is where? This is the equation number 2. X of n is equal to this one. Standard equations. 2 and 5. 5 is this. Right? 5 is this equations. Right? x star n place I am substituting x of n because it is given. X of n is equal to 1 over 2 pi integrations of 2 pi x star of e power j omega. Only change is e power j of minus omega n. Instead of into d omega is also same. Into, now see, this is e power plus j omega n. Here it is e power j minus omega n. When you compare those two, we can write like this. dTft of x of n as x star of e power minus j omega. This is very, very important. Call this equation number 6. How do I write? Now see, the dTft of x of n is given as e power x star of e power minus j omega. Because this is minus j. Here see, minus omega is there. It is not plus omega like our previous. It is minus omega is here. That is why I am writing x star of, see this, x star of e power minus j omega. This is minus sign is there, no? That is why e power minus j omega I am writing. If you write this, it is what? Then call this is equation number 6. The RHS dTft of x of n is x star of e power minus j omega is there. When you compare this with equation 1, RHS of equation 1, what is that? See this RHS of equation 1, this is equation 1, RHS is x of n is x star of e power j omega. RHS of, that is equation number 1. RHS x of e power j omega for the x of n. Here RHS is x of n is x star of e power minus j omega. Then compare 1 and 6 RHS only. Therefore we can write x of e power j omega as x star of e power minus j omega. Right, very, very important. Compare RHS of both 1 and 6 because LHS is x of n both the case. Right? Then what you have to do? Then final answer you will get. Then see the modifications to this maths. Just take conjugates on both sides. We get x star of e power j omega conjugate is equal to x star of e power minus j omega whole star. Star of star gets cancelled. You will left with x of e power minus j omega. Call this equation number 7. This is what? Equation number 1 is, statement number 1 is proved. Hence property 1 is proved. What is that? Property 1 says x star of e power j omega is equal to x of e power minus j omega. If you take out this star conjugate, minus sign comes inside. That's what e power minus j omega. This is what the property statement number 1 we have to prove. Right? See this? If x of n is real, then prove that x star of e power j omega is equal to x of minus sign comes inside e power minus j omega. That's what equation number, statement number 1 is proved. Statement number 1 is proved. Here x star of e power j omega is x of e power minus j omega. Call this as equation number 7. Now I want to prove the second one. What is second one says? Very simple. X of n is real and even. Then prove that only purely real terms you will get. X of e power j omega, purely real terms you will get. This real only you will get. Imaginary becomes 0. It is easy. Let us see now. Right. Similarly for equations for statement 2. What is that? You have to assume. This is given. X of n is real and even signal is given. Therefore we know that from equation 1. What is equation 1 says? X of n, where sequence is written as sum of xc of n plus x naught n, which is equation number 1 only. Right. dTft right side is x of e power j omega. Right. Frequency number, that is nothing but xr of e power j omega plus j of xi of e power j omega, equation 1. This is given. Right. Already we know. Right. What is that? In the frequency domain it is real plus imaginary. Now just substitute n is equal to minus 1 into equation this one. N is equal to minus 1. Just deflections. Right. N is equal to minus 1 here. You will get xc of minus 1 plus x naught of minus 1 dTft. X of e power j omega is nothing but frequency domain also x of e power minus j omega. Like this only. Substitute n is equal to minus 1 minus n into equation 1. Mirror image will get. X of minus n is equal to x even part of minus 1 plus x naught of even part, odd part is minus 1 dTft. X of e power minus j omega instead of plus j omega minus j omega, which is nothing but x of e power minus j omega just now proved is equal to x star of e power j omega from equation 7. Now see this. X star of e power j omega is x of e power minus j omega. This I am having, substitute this. That's what I am doing. Now see. X of e power minus j omega is x star of e power j omega from equation 7. Which is equal to, this is equal to x star of e power j omega is nothing but what? Conjugate of x of e power j omega is nothing but x real part of e power j omega. Conjugate means minus. Minus j xi of e power j omega. Call this as equation number 8. Now, from the above equations, we can rewrite this as x of e power. Just simplify this. X of minus n as x even part is nothing but xe of minus n is nothing but plus xe of n. Like cos of minus theta is equal to cos theta, like even. Then similarly odd is x naught of minus n is minus x naught n. That is nothing but sin of minus theta is equal to minus sin theta. Left hand side over for this. DTFT right hand side same. X of e power minus j omega which is equal to x star of e power j omega from 7 which is equal to real part x star of e power j omega minus j xi of e power j omega. Call this is equation number 9. Then add 1 and 9 you will get the even term. Add subtract 9 from 1 you will get odd term. Now let me first add 1 and 9. 1 and 9. This is 1 left hand side. This is 9 left hand side. Now what will happen? X left hand side you see. This plus this is 2xen. This minus this is getting cancelled. Right? Sorry. This 1 is this. This plus this is 2xe of n. This minus this is plus this is getting cancelled. So LHS is 2xe of n. Similarly DTFT right side is 2xr of e power j omega. See this? Right side is xr of e power j omega. xr of e power j omega. 2xr of e power j omega. This is getting cancelled. Plus j minus j. Therefore, answer is 2xe of n DTFT is equal to 2xr of e power j omega. Only real term. That is nothing but 2 gets cancelled. DTFT of even term is xr of e power j omega. That means if the sequence is x of n is real and even, then DTFT is only real terms it gives. No imaginary terms. Similarly, that's what DFT of real and even sequence is purely real. 2 is true. Similarly, 3. For 3 only one change. That is, it is nothing but what? No imaginary terms. Right? Hence the proof. Then, if you want the third one, subtract 9 from 1. That's all. Subtract equation 9 from 1. What will happen? Similarly, 2x naught n is DTFT of, we will get 2j into xi of imaginary terms we will get. Xi of e power j omega. Just see this. See this one. 1 is left hand side xe of n minus 9. That is xe of n. This gets cancelled. X naught n minus of minus x naught n is 2x naught n. DTFT, this real terms cancel. Plus j, plus of minus is plus. 2j xi of e power j omega you will get. That's what I am writing. See, 2j xi of e power j omega. Therefore, DTFT of x naught n is only imaginary. J into imaginary xi of e power j omega. No real term of x of e power j omega exists. 0. Real term in frequency domain is 0. Therefore, DFT of real and odd sequence is purely imaginary. That's why this is very, very important property. What is that? This is very, very useful now. Useful property. Why? Because if you want to calculate half the sequences in the frequency domain, if you want to calculate, for example, 16-point DFT I want. Let me take example. 16-point DFT samples we want to calculate in frequency domain. Out of 16 point, let's say, suppose 16-point DFT I want to calculate. Then what you will do? Using this property, only half the points of 8 point, 16 point out of that, only half point, 8 point DFT is to calculate 8 points. Other half we need not have to calculate. Other half of the points we need not have to calculate. One line formula if we use, we can calculate other 8 points. 9, 10, 11, 12, 13, 14 samples, 15 samples you can calculate. That is why this property is also called as labor saving property. That means it saves processor times of other 8 samples. First 8 samples if you calculate by using 2 page, other 8 samples you can calculate by using 8 lines. Right? That's why this is called as labor saving property. It saves processor time exactly half the amount, which increases the speed of the processors for today's applications. That is why symmetric property is very, very important in today's applications. Let me quickly repeat within the 3-4 lines. What is that? For example, this is the statement. DTFT of x of n is this. Then real, then prove this x star of e power j omega as x of e power minus j omega. If it is real and even, then there is only purely real terms. If real and odd, only imaginary terms exist. Then prove x of n is real means x of n is equal to x star of n. First write x of n as the combinations of even and odd part. Similarly, we say even and odd part. Call equation number 1. Write original equations of x of n. Right, with respect to frequency domain x at p power j omega, call this is equation number 2. Then take conjugate on both sides, will get x star of this, x star p power plus j becomes minus j. Write this minus j omega n as minus omega inside. Call this is equation 3, 4. Then apply the given x of n as x star of n. Then we can write x star of n as x of n, write the same one, 5. Call this is 5. Then compare 2 and 5, we can write DTFT of x of n as x star of e power minus j omega. Why? Because it's x star of minus j omega. Minus term is there here. X star of minus j omega is there, unless like this. Right, here it is. Here it is not like that. It is only omega plus. That's why that. Then after that, what you do? Take from 1 and 6, call this equation number 6. 1 and side 6, we can write right side only. X of e power j omega as x star of e power minus j omega. Then take conjugate, you will get first one. X star of e power j omega is equal to star of star gets cancelled. X of e power minus j omega. First one is true. Similarly, go for second one. Write first one, first equation as it is. Substitute just n is equal to minus 1, minus n. Then write this. Call this is equation number 8. Then solve this according to even and odd. Call this as 9. Add 1 and 9. You will get even term as purely real. Subtract 9 from 1, you will get odd term only, which is purely imaginary. Hence the property proved. That is why this is very, very useful property, because of the sequence out of 18 points, if you take, it is calculated by direct method. The other of 8 points, you need not have to waste 10 pages. By using this property, within one line you can calculate. That is how it saves processor speed actually. Processor speed, and today's applications you need speed only. Right? That's all. I hope I am clear. Thank you very much. Next sessions we'll see problems on these properties only. Right? Now, before that, again let me read out this quote, very important quote. Right? What is that? Successful people, right, will always find solutions for each problems. Winners or successful people, whoever you call, they'll always find a solutions for each problem. Whereas unsuccessful or negative people, right, they will always, right, create always problems for each solution. Whatever solutions you give, they will give you one problem for that. Right? Therefore, so students, you students or anybody, go on finding out solutions for each problem. Don't worry about the rest of the things, positive or negative. Right? By saying this, thank you.